Now let's talk about the types of definite integral equations. Single definite integral equation, double definite integral equation, triple definite integral equation, and so on. Single definite integral equation. What is single definite integral equation? A single definite integral equation has only one integration sign. We can see here that it has only one integration sign, with only two limits start from a to b. An example to know that how it can be solved: integration of x dx. The limit a is 0 and the limit b is 1. Integrate x with respect to dx, we have x squared out 2. Now substitute the limit 1 and then the limit 0, subtract them, and we got the final answer 1. This is single definite integral equation. Double definite integral equation. An equation which has two integral signs is double definite integral equation. We see here that we have two integral signs. The limit for the first integration is from a to b, and the limit for the second one is from c to d. An example is double integral of x plus y dx times dy. This integration is with the dx and the other one is with the dy. We're going to differentiate the given function first with respect to x, and we'll put the limits from 0 to 3, and then with respect to y, and we'll put the limits from 0 to 1. This is the procedure to solve the double integral equation. Triple definite integral equation. How triple definite integral equation looks like? We can see here that we have three integration signs, and that's why we call it triple definite integral equation. Triple integral of x, y, z dx times dy times dz. The first integration is with the dx, and second one is with the dy, and the last one is with the dz. The procedure to solve the given function is that first we differentiate it with respect to x and put the limits from 2 to 3, and then with respect to y and put the limits from 1 to 4. Then with respect to z, the limits is from 0 to 2. At some places we have the variable for the limits. Now it is not compulsory that you must have a constant number like from 0 to 2 or from 2 to 3. Sometimes the limits can be variables. This integration is with the dx. Now make sure if you differentiate it with respect to x, the limit has to be another variable. It shouldn't be x. Like we see here that we differentiate it with respect to x, the first integration, and the limits are y and y square. The same goes for the dy. If you differentiate it with respect to dy, the limits are different. The limit has to be other than y. And the final one is from 0 to 1 for the dz. Again, the procedure is first differentiate it with respect to x and put the limits from y to y square, and then with respect to y put the limit from z to 2z, then with respect to dz and put the limit from 0 to 1.